Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Started, and Wenming has more demos to show.
Yeah.
Yeah.
So I guess everybody had a nice little break. I always like to make sure that you guys get your full 10, 15 minutes full break so that you can actually absorb what the talk is all about. A lot of times I actually go to a lot of talks, and to be very honest, half of the time I probably get lost after, I would say, 30 minutes of the talk. And I know I'm, very primitive in terms of understanding new technologies, but it turns out that it's, I would call it the conference anonymous. Turns out that my colleagues and other people that I know didn't quite understand a lot of talks either. So I would like you guys to ask questions if you like, and we'll just try to make it a bit more interactive. We have an hour. I'm the person that's between you and lunch as well. So I completely understand. So let's kind of take a look at what's going on. So here's what I did. I actually remote terminal serviced into the head node of that cluster that we created. So I typed a simple command called node list. Really simple. All I just wanted to know is what's going on with all these nodes that I just created with Azure. So I asked Azure for 10 nodes. And initially I asked for 20. But it says your subscription does not hold 20 because it's somebody else's subscriptions. I think they put a restriction on me. So I could only have 10. So I said, OK, start 10. And so I typed node list. And as you can see, I had 3 nodes initially. So they're all online. 1, 2, 3. So these guys are online. And there's a bunch of them offline, which means they actually I got these nodes running. But they're offline. They're just waiting for me to issue the magic command. And I know there are 6 of you, and you have to identify yourselves. I'm kidding. That submitted jobs while I was away. So while, during the break, or maybe when I was talking. So the first thing I'm going to show you is that this is the cluster job manager, which means it's showing you what's going on actually on the cluster. So, what has finished, what has failed. 400 jobs have been submitted, so which means 400 job weather simulations has been done. And prior to that, there's actually a few hundred more. The interesting thing is that I can kill the entire thing right now and still have all the data available because they're stored in the blob storage and also table storage for all the jobs. So I don't rely on this cluster to, I assume it's going to come and go. So it doesn't really matter. So tomorrow I can spin up an entirely different cluster as long as I still have my storage account. So if you lose your storage account, you're gone. But if you have your storage account, you can turn them off, turn them on, and always save your data back to the storage. So storage is simply a copy operation, or you can also mount the blob as a drive. It will show up as a drive if you wanted to do that. So it's really simple to operate in that environment. If you want to learn anything about how to do that, go to the Azure Training Kit. It will teach you all about the basics. So there are lots of jobs that finished. So what we're going to do is we're going to take those nodes online. So I'm simply going to type node online. Anything that says offline, I'm going to turn them on. So let's do a node list again. So most of them are actually starting to come up. So as you can see, here's something interesting. So you can see nodes 11 through 14. Here's the artifact of when I started allocating them initially. I said I want 20 nodes. But the scheduler comes back to me and says, I don't have 20 nodes. So what it did is try to do as many as it could, which means it allocated 14 nodes. And then I went back and says, give me 10. So as you can see, the 10 would actually be online. So up to here, so 1 through 10 should actually be either online or offline. And 11 through 14, I never really allocated. So that's kind of how it's working. So what I'm going to do is I'm going to start taking them all online. Compute node, let's see, 4. Oh, oops. I put a little space in there. So you guys can tell me like 5, if I missed any, 6, 7, and 8. And you don't have to do this manually. It's just that there's a default configuration where you can turn them on immediately. I just chose to have them offline. So now I have all of them online. And you should see that the other jobs that were queued, there were 4 of them that were queued, are now running. So you can see that all these jobs are actually running. And now we can go back to the portal, which is the web portal, and see that these things are just running, are going to start running. So there's one caveat, which is that, as you can see, it's still in a busy status inside the Azure portal. What it means is that I'm actually preparing these nodes in the startup tasks. The startup tasks are installing Python, installing partial Cygwin, which I needed to run GDAL and some of the utilities, also it has to set up the data and some of the other operations, like make sure that the scheduling is happening. So there's some preparation that needs to happen here, but when it's all done, it will start running these jobs. So let's go to the portal, and let me see if I can. I think I killed it. So that's the nice thing about web-based application, is that once you killed it, you can just go right back. And let's see, list all forecast. As you can see that all of them are starting to run. So you know what you submitted. So I'm not going to ask, but you guys are feel free to submit a few more. And it takes about 8 hours. So at the end of the day, this evening, when you're done with our drink party, you'll be able to see weather forecast. The interesting thing is it's actually queued up. It will wait until it sits in the queue, but it will always grab the latest initial data from NOAA, and run it. And once I have it set up, it will continue to run, and I don't have to worry about the IT department turning it off. I don't have to worry about losing the code. I don't have to worry about pretty much anything, because we have to keep this running. There's a lot of businesses running on this. So the fact that it's mission critical, I mean, these public cloud systems will ensure that it will have much better, what is it called, 99%, what are those, service level. So it will be better than a few of your students running a couple of Linux boxes, and hopefully the sysadmin has enough money to pay for electricity. So it will just keep on running. And if you don't need to use this, turn it off, and it doesn't cost you anything. So my understanding is that all desktop computers are only 5% utilization. And I think servers are around 10, 20, which means if you know how to manage turning this thing on and off properly, you're going to save a lot of money in the long run. And also, really in terms of the reliability, and also writing your software correctly and in a stateless manner in the very first time is also really money saving in the long run, because one graduate student graduates, your project just going to sit idle. I think I heard that story yesterday, or maybe it was on Monday. So you're not people dependent. It's just going to run. So I really enjoyed doing this project. I think having it running for a couple of months really gives you a lot more confidence. Before, I just probably wouldn't have done it. I think it's really about doing a project with the cloud and be able to understand the benefits. It will be a lot better. So I encourage you guys to take this and play with it, and see, if you can take your scientific workflow and make it right without writing a whole lot of code, actually, be able to deploy that into the cloud and try to make it into a service. And the second nice thing is that you can share it with the world. So right now, I actually have random people submitting all kinds of stuff on here. And some of them are just me, but there's just hundreds and hundreds of interesting things. And it also makes a very good educational tool, because I bet I don't think there's another service in the world that allows you to do this sort of stuff. So you can play back the precipitation. This is in Miami, okay. And also, wind speed, a lot of events. Actually, I found that some of the folks from NCAR actually logs on and types, does a little simulation. And I would know what kind of events there are. So I think they were looking for validation. So it's also a way of keeping a golden copy of your code that has been working. It's called the production copy. So I really found that to be a very good software engineering practice. So any questions?
Suppose you then want to use the output. How do you actually get the data?
So the data is in Blob Storage. So I keep all the data in the Blob Storage. So some of them I actually started deleting because it produces about 5 gig per run. And it's going to overrun my storage very quickly. So what I instead did is I keep all my GIFs and animations, all the overlays. So I keep the images, but I don't keep the data. But I can keep the data if I want to. So what that is, it's very easily accessible. All you need to do is to use one of these tools like Azure Storage or something. Azure Storage. So we have a lot of interesting open source projects that's out there that you can simply run. So yeah, I have a lot of fun little projects, but let's see if this one allows me to log in. So here's the Wharf Storage. If I can get this thing to load. So if once you log in, you'll see them as just simply files. And you can, mount a blob storage over as a drive and keep writing to it. So that's the persistent store. And it's actually pretty cheap. I think it's, yeah. When do I scrub it? It depends on you. What would, you run when your credit card runs out, or when the data is no longer important. You can do whatever you like with the data that you store on there. So for example, I know people that store medical, some of their medical data on it. And what's interesting is that they kind of gone exponential. So they're storing, I think it was 18 gigs initially, and then it's like 60 gigs and 130 gigs. And then what's really good about it is that we replicate it 3 times, and also we geo-replicate that. I don't know what is going on today, but I know why. I probably have the wrong key. I don't have it stored in this storage. But when you browse, it looks just like an FTP site or any of these. I just recently cleaned out a lot of my machines, so these accounts are no longer valid. But if you log on, you're just simply dragging and dropping files. It's not really complex. You can also automate it. So we provide a REST service, and you can use curl if you wanted to. In fact, you can use Python, you can use curl, and you can pretty much use anything that supports REST. The nice thing about writing .NET code is that you don't have to go parse XML, right? I mean, that's just not very exciting. So there's Python tools out there. By the way, Microsoft actually has something called the Python tools for Visual Studio, which turned out to be super slick. I've been using it a little bit, and I really found it to be very cool. So I do a lot of Python code for big data type of manipulation, clustering of data sets. But we have we have Python. So Python will have a lot of Azure support, which I think would be very good for people who want to do it from another platform. So just the other day, I was just sitting down thinking, how do I access management and upload management certificates and all that through on Linux? So I was sitting on a Linux box. So it took me about, I would say, 35 minutes to figure out how to use curl to access the management API. It's really simple. You're simply running against a REST service. And you can use that for compute, storage, or anything you want. But in terms of cost, it does cost money. I think it's, I don't quite remember, around 10 cents per gig per month, which is, but it's replicated 3 times. We ensure it's always going to be there. And in fact, a lot of my colleagues, they use their own personal credit card to store their family photos and all that on storage, because you have it geo-replicated, so anything happens, your data is going to be there. So and also I think at some point we talked about how to access things like a Blob, what is it called, the Dropbox and other type of things. So in the cloud, a lot of things are REST-based, so you can access Dropbox from Azure compute services as well if you really wanted to. And it's just simply, you have an API key, and you probably use HMAC for authentication. You would be able to grab data, operate against other storage services, even Amazon S3. So it's all interoperable. SkyDrive, I don't know. I haven't tried it. I don't know if they have a REST API, but I would assume they have one. SkyDrive has, was it 25 gig free? That's really nice. I should probably look into that. But this doesn't cost you much either. I mean, it's just what is a Dropbox is getting expensive. I think I have it. I think it costs like $100 or. But anyway, the point is that this ingress is free as well. So if you upload lots of data onto the cloud storage, it's free. And also, I know this is like kind of a public venue, but I certainly don't mind telling you guys that we have some new HPC hardware in the works. So they're going to be specialized, very fast machines. I can't disclose exactly what they are, but you guys should be on the lookout for these new hardware, which is actually really going to be really, really nice. I can probably take my simulation and run it and take it from 6 hours down to a few minutes once we have the HPC hardware. But the important thing is the abstraction, the ability to share, and also the ability to collaborate, and the convenience of the cloud is really important. At the end of the day, it does save you a lot of time and money. And also, I encourage people to develop their software in a stateless manner, regardless of what platform they're on. So it will always save you a lot of money. I remember my advisor always told me that you always have time to do it right the first time, and that has worked out. Saved me a lot of time. Was that advice? So that's kind of what I see from a lot of scientific computing places, that code is written in kind of a hard-coded way because people think that they don't have time. But in the long run, you will save yourself time, especially for the grad students here, is that it will come back to haunt you if you write your code in a sloppy way. And it has come back to haunt me. Yeah. Yes, sir. That's a really good question. So MATLAB has, we're actually working with MATLAB. So what their model is that they're going to put licensing servers in the cloud to probably do that. And also they could also, sell you a desktop version. It's kind of the burst model where they launch their cloud instances from your actual desktop application. So that's a possibility. I mean, the simplest way to run a MATLAB code on the cloud would be GNU max it, take the binary and shove it onto the cloud and run that. Yeah, but yes, they will have MATLAB running on the cloud. I mean, we are trying to solve a lot of these problems. So there are a lot of different scenarios running stuff on the cloud. The simplest way by far is something as a service. So I think that goes a little overboard over here as a joke sometimes, but anything as a service essentially. So it would be probably Office 15 is obviously a what is it called? 365. Sorry. That's a service. Google Doc is very clearly a software as a service. And then you go to platform as a service, which it has a lot of the global services done for you to enable you to write a cloud application. So, for example, we have Service Bus. We have these blob, the storage services. We have all these infrastructures allows you to make your application stateless. I have to explain Service Bus a little bit. So essentially, it's a pub-sub model of getting notifications, and also we have just things that really enable you to build a global application. So these things are not necessarily applies to everyone. It's just like it's an overkill for me to go buy a bus right now, but it's there once you want it, and it's for rent. And the fact that the public cloud is available today enables a lot of interesting scenarios. So the next piece I want to talk to you guys about is Hadoop on Azure. So this is a data conference, and I do want to explain a little bit about Hadoop. So how many of you actually have heard of Hadoop or have started using it? Started using it? Would you guys like to come up here and talk about it? So I kind of started looking at Hadoop, I would say, about a year ago, and I found it to be, very interesting. I think the main thing about Hadoop is that it has a ecosystem where you have a lot of interesting things that's built on top of it. So, for example, if you want to do machine learning, there's Mahout, and if you want to do page ranking, there's Pegasus. There's a lot of stuff that sits on top of it. So it allows you to take advantage of all these tools. And also there's a lot of applications that are starting to be built on top of Hadoop. A lot of bioinformatic type of applications, gene sequencing, and also anything that has to do with graph. So we actually... So Hadoop is really about MapReduce, taking a large amount of data and distribute it onto the cluster and be able to move your compute code onto the nodes that contains the data. So it's a pretty straightforward concept to understand. But what's interesting about it is that it kind of goes from the same route where HPC stands. So it kind of takes the database, the monolithic database story where you have to buy these giant, Superdome machines with, MPP processing, and just simply say, well, I have a lot of data, and they may not have a schema, and I honestly don't care that much about them, but I like to extract information from this massive amounts of data. So what do? So you buy a bunch of commodity machines, and I have to note that when they say commodity, it doesn't actually mean your 10-year-old PC that's sitting under your desk. What they really mean is server class machines that are cheaper than these database boxes, but not necessarily as cheap as just your $200 PCs. So let's kind of go over that. And I have all of these presentations in the training kit, so it's easy to go do. So the way you find this training kit is you go to download.microsoft.com and simply search for Azure Training Kit. You just find it. I mean, it has all the stuff in there. And I keep, I like to kind of keep referring to that is because we spend a lot of money on this. So I like to, have as many people take advantage of it as possible. So let's open this presentation, and I'm going to run a little run a little demo of it real quick. So here's the Hadoop. So 1.7 zettabyte, that's a lot of data. And I honestly think that, well, we're not really storing all that data. We throw most of them away. So people actually think that we store this data. No, we don't. So what ended up happening, probably 1% or 2% data ever gets saved. But the real problem is that it gets bigger. And the velocity goes much bigger as well. So for example, one of my former boss works for GNIP, which is a Boulder-based company. So I'm from Boulder, Colorado. So I work for TechX Corporation, which is a DOE contractor. So one of my former boss started working for that startup, and I kind of learned a little bit about what that company does. They have a full pipeline. They have one of the two, maybe, full pipeline of Twitter. So essentially anything that tweets every day, I think it's 155 million per day. So that's not just that 140 characters. It's also metadata. It's also web pages, the actual, maybe the text or the PDF or anything that it links to. It comes with a link. So you have to include all that stuff. So your pipe suddenly becomes huge. So big data, the rise of big data really came from social networks, where just suddenly you have a globalized application where you're storing a huge amount of data, which is not necessarily structured. So they're not structured, meaning that they don't have a schema for it. So it's just data. Before that was search engines. Search engines also big data. Bing has, I think it was petabytes and 7 petabytes a month. I mean, that's a lot of big data. And I don't even think that Bing would be able to, do a lot of this in-house immediately, because this is just a huge amount of data. 155 million messages, that's 1 terabyte a day. I mean, it may not seem like very much, but if you multiply it out, and that's 1 terabyte per day, and it's still growing. There's just a lot of data that people want to process, not just simply by batch systems, but also in real time. So you guys probably have seen this issue of data delusion. It's essentially saying that what are you going to do about it with all that data? So here's some example scenarios. Traditionally, there's this database world where you have your enterprise data warehouse, and you process some of them, and you store them, and you throw away the rest. And now people are starting to realize that all data has value to it. What's interesting is that Facebook and Twitter, they can figure out a lot of interesting things about you. And also there's location data. And I don't really have to explain data to you guys, because you guys have a lot of scientific data. How many of you have more than 1 petabyte of data? Oh, you have? Okay, well, yeah. I can't even imagine how we're going to store that. I think the IBM was going to do a telescope or astronomy project, which has, I think it was 1,000 petabytes. 1 exabyte. I think it was 1 exabyte worth of data. Oh, okay. Woohoo! That's a lot. So the idea is that you use these commodity machines and use their hard drives to distribute the work out, and it's really not just about amounts of data. It's also about the variety. There's different types of data that comes in, right? So there's social network data. There's log data. Actually, log data is a big deal. People really mine their log data to figure out where, they know exactly where you've been browsing for the last 12 years. And they could actually probably structure a timeline of what you're doing every evening. That's starting to sound really scary. But on the other hand, there's also can be used to discover, interesting good things, which is what you guys are focusing on, which is how to use big data for the good of mankind. And also the velocity, right? So we just talked about that. I mean, everybody not just simply tweeting, and the data from your sensor network is probably going 24-hour continuously being stored somewhere. So who's doing sensor network here? I know a bunch of you guys are doing. So where do you store that? Is it stored in a database, or is it stored in one of these, NoSQL type of data store? You do both. Okay. Yeah, as flat files. Yep. Yep. Yeah, into a database. So do you delete something? Do you pre-process them first? Because scientific data in general is already structured. Okay, so it's already structured in some way. Okay, so that's a big difference. And actually, that's one of the distinctions I like to make, which is big data, the industries, the big data growth is really about unstructured data, which means, the social network is a big part of it, and also being able to do things in real time. That's another hot area where a lot of financial institutions invest a lot of money in. And also scientific data, which has always been around, but that's nothing new that we have to do. So, so here's how things work. I mean, obviously, you guys know how data works, and I don't have to explain that very much. But it's really about, MapReduce is really about taking your code and map it to where the data is without having to move it very much. And instead of using a database, you're using the local storage of these machines. And the MapReduce workflow can be changed into many different layers, or not really layers, but pipelines, or you can pipelines. So you can do MapReduce for at many stages to produce some results. And I think there's a term called iterative MapReduce, which Microsoft Research has a great project called Daytona. I think it's still running, which allows you to, which is optimized for the cloud. So the cloud system is a little different from on-premise, meaning that the storage is actually not necessarily the local storage. You can use the local storage, but that's temporary. So all your storage actually has to go sit in a centralized storage like the Blob store. So the operation and the algorithm becomes a little different. What they do is they add caching layers. They add different types of optimization to make sure that it's fast enough to be able to solve your problem. So I would encourage you guys to look at Daytona. Not necessarily the actual code, but look at their paper to see how they optimize, MapReduce for the iterative MapReduce for the cloud. But Hadoop is, even simpler than that. So it's just simply MapReduce. Okay, so there's, this is actually exactly what you guys do, which is data acquisition. You do your collaboration. Visualization is a big deal. How do you visualize a huge amount of data? Do you do sampling, or do you actually try to read all of them in? So those are the challenges that the industry has, and I think they have a lot to learn from the scientific community about how to visualize a huge amount of data. So we have tools like in HPC, we have tools like Visit and ParaView to do parallel visualization. So a lot of that would eventually be done in a parallel fashion for visualization as well. So visualization is also really expensive. So here's how Hadoop works for those of you who don't know, which is that you have job trackers, which tracks all your MapReduce jobs that gets divided up onto the cluster, and then you have your data nodes that's controlled by a name node. This looks very familiar because you're operating in a clustered environment. HDFS is sort of a meta file system, and I'm pretty sure it's replicated 3 times. And you guys would, you guys who have played with it probably know it a lot better. Do you guys keep it the replication 3 times as always, or do you guys shut it down to or reduce it to 1 only? Hadoop. For the file system. What do you guys do with the file system in terms of how many times your data is replicated? Twice? Okay. Oh, okay. Yeah, and you can start running Hadoop on your local workstation. Even if you had just one node, you can just download this. It's just a bunch of Java code, and runs a bunch of services. And you can start, running your code, playing with it just on a single workstation. So it's not really hard to start playing with Hadoop. Here are the differences between RDMS versus MapReduce. MapReduce is really about linear scaling and keeping the cost low more than anything else. As far as I'm concerned, it's a batch system, and you don't read very often. But that's all going to change in the future, I'm pretty sure. So with the new HBase tool set, they're modifying it to be to sustain a lot of writes. So all these things can be optimized for what you want to be doing. But the main difference is that it doesn't have a schema, and it tries to scale linearly by using cheap commodity software hardware that's clustered together. And here's the ecosystem that I talked about a little bit. So Pig is for workflow, and Hive, I actually have a quick demo to show you. And then Scoop is for importing and exporting data in and out. And then there's stuff like HBase, which is a column-based database. ColumnDB, where you can just shovel a lot of data in there. There's something called Cassandra, which is kind of equivalent. So there's a lot of tools that sits on top of it. And then there's the analysis tools like Mahalt. I don't see it in here. It's not in here, but there's like Pegasus. A lot of these tools that allows you to do, provides algorithms for you to do clustering of your data set. And one of the things that I used to run quite a bit is running information retrieval using SVDs. So apparently Mahalt has a disk-based SVD solver. I thought that was really interesting. It just runs really, really slow, but it will be able to operate on a much larger scale than your linear algebra library that's sitting in memory. So that's also a difference between HPC and big data, which is everything is, you're focusing on the disk I/O side of things. So we actually provide a Hive ODBC driver, which I'll show you a really quick demo of. And then there's the rest of all these interesting things that you actually saw. There's Power Pivot, and you guys probably, did we show any demos about Power View so far? We haven't? Okay, so Power View is part of SQL Server 2012 Denali. Basically what Microsoft is doing is actually, I really think it's great, is it allows you to take open source software and interoperate that with the commercial quality software that we produce. Allows you to have a lot more flexibility in terms of cost and also development time if you want to use the commercial side of things. As you can see, that open source code is generally a little flaky in terms of stability, but as we support Hadoop, we'll make it a lot more robust and also a lot easier to use for people on the Microsoft platform. But we also will contribute the code back to the Apache Foundation to make sure that people on other platforms can take advantage of our changes as well. What I want to show you is that maybe a demo real quick. I think that would make it more interesting than going through all the slides. So the portal is called Hadoop on Azure, and you can actually go get a free subscription. So if you go to connect.microsoft.com, you'll be able to log in. So I'm going to type HadoopOnAzure.com. So once you go on there, it's really, really simple. Just think of Hadoop on Azure. And there's an invitation. You can click on it. It may take a few weeks, but you actually get a cluster. Think about it. It's the free Azure you wanted. So it creates a little cluster for you once you sign in. So I'm going to sign in here with my login. So this is a typical example of software as a service. In this case, the software is Hadoop itself. So I think I'm trying to sign in, or did it sign me in? Oh, there you go. Yeah, so I think our product team is very funny. So here's the very simple UI. Since I'm showing you on the a very large, largely amplified screen, I can show you basically, you have a little interactive console where you can play with your code a little bit, and you have a remote desktop. You can log into the cluster where you just initiated, and also keep the ports open. You can FTP in. I know everybody loves FTPS. You can use curl and other tools to FTP in, and you can manage your data. You can connect to your Blob Storage, which is the Azure Permanent Storage, or Amazon S3 if you wanted to, and you can import data from Data Market, and we're going to show you an example of that, how to do that. So it looks like I have a little bit of data. That's not very much. So I have a 4-node cluster, which means it's fairly small. You can have up to 32, but in general, you probably don't need that much. So this is more of a development environment than anything else right now. So this is a preview of what Hadoop on Azure looks like. So let's just run some simple samples, or actually at least look at the samples that I ran. So here is a 10 gig Terrasoid that I started a while back, and it's still running apparently. So you can Hadoop is Java based, so you can you simply type in hadoop.command.jar, and you have one of the examples, and you just run it. And that's Hadoop. You're just writing Java code. I mean, more than anything else. But what we did is we actually added a little bit of Java console to it, a JavaScript console. So you can actually script against Hadoop if you really wanted to. I think I was showing a little example earlier, but we can do it again. Okay, so here's a JavaScript console. So you can actually access all the file system. Isn't that cool? I mean, this is very much like a Unix file system, but it's not really a Unix file system because you're operating against the distributed Hadoop FS. So the command you're actually typing, going back and forth, is Hadoop FS ls. Right? The command is ls. So you can see I have some files there. But what I'm going to do is I'm going to run some simple examples. Let me see if I can find my demo script here. I'm just going to type that in real quick. It's going to take me a while to actually type it. So what you can do is you can type a pig command. Pig is the workflow engine. So you can type something like this. Obviously, this is wrong. I have to type. So they changed it a little bit. So it's not quite the same as before. So what I can do is I can say, word count. So I have 4 files up there, which I do want to do a word count of. So I'm going to run a MapReduce job. So Gutenberg is a directory, which you can see. It's Gutenberg. I have 4 books in there. So I'm going to do a word count on 4 books. And I'm going to run a MapReduce job, which uses the JavaScript code. And I am going to order them by the send and take 10 of them. So essentially, I want 10 words to be in there. So I can just go ahead and run this job, and then I can show you. I'm going to call it top 10 2.2. And I already have a job that I finished, which I can visualize very easily. Pound ls. So I have the results as Gutenberg top 10 from before. If I want to visualize what it has, I can simply type, I think it's file equals fs.read, gb top, Gutenberg top 10. Let me see if I can type that in. So what I'm doing is that I'm reading in the results and try to visualize it right here on the console. So there's 10 words and there are occurrences. And then I can do a little plot. I can say data equals parse. I don't remember what it was. I think it was parse. Let me see if I can find this. Yeah, that's right. So you want to parse the data file itself. So this is all just simply pig commands, but we allow you to do that in JavaScript. So I'm going to paste that in. Data equals parse. Did I have that right? So I just parse, that data set, and then I can say graph, graph.bar data. Oop. What did I do? Oh. Hold on one second. Capital D? Oh, I didn't spell it right. Okay. Oop. There you go. So I can, just do a lot of interaction right there on the console without having to, deal with all the jars. But at the end of the day, I think people just really want to run something, have a little development environment, log in. They don't want to manage their clusters. What's funny is that I'm not going to mock, things on premise since I'm the cloud evangelist. Is that I actually was looking at, some of our hands-on labs that you would actually have to do to get your cluster set up. Just really under any environment. This is no different from developing on any other platform. So just look at this this hands-on. It's 44 pages, and 40 pages of it was setting up the cluster. Look, have to set up your VM, more VM, more VM, set all this up, and by the time I spent that time playing with it, I'm not really focusing on the problem at hand. So that's the power of the cloud, and it just keeps on going. So the point is that Hadoop on Azure is a really interesting direction of taking things into from software as a service. And we also have done a very good job of being able to import and export data. So the simplest thing, you can upload the data. So how do you upload the data to the file system? So you can simply say in the JavaScript console, f.put, and browse locally, and you have a file up there. I don't know, what would I want to, there you go. So I can, that's my 5 gigabyte email archive. Okay, but let's just find something that we can upload. Hadoop on Azure. How about this? I will just upload a big movie and upload. And it's just asynchronous because I can actually, still browse what's in there. But it's uploading in the background just simply by typing a JavaScript command. So that's the simplest way of using it. So how do you use that with Excel? So I'm going to play that video that we showed you earlier. So this is something that I built a while back, maybe half a year ago. 4 months ago. So what this is doing is taking data from Data Marketplace. So I log in and get into my account. And I will go to Data Marketplace and import some data set. So it's really, really easy. All you're doing is that your username and password, you can create a free account on Data Market. And you can use mine if you really wanted to, but I think that key expired. And then you can, for the query, it's really simple. You go to one of the data set and come back down here and just grab the HTTP API. I think this is OData. So just grab the OData API and put it into the query. And you want to import that into the Hive table. Hive is their enterprise data warehousing thing that sits on top of Hadoop. It's a column, it's not a column DB. It's a fully featured database tool. So I said import. So I imported all the data. And then I'm going to go back to the interactive console. And I'm going to run a query against the data that I imported through OData. It's real simple. All I'm saying is that I want the maximum crime through the city. And then I just type in the query on the screen without having to touch anything. Don't have to log into the machine. Just type it in. And go to Excel. Install the Hive ODBC driver. It's just executable. Install that. That's already installed, obviously. So just type in the machine you want to, the cluster you want to connect to. MapReduce, and my name and password, and hit OK. And you can query against cluster right there from your desktop. Obviously, I did I don't want to move all my data, but only the results. So I did a select, and I told it to limit to 10. Once I did the actual query. Okay, so I'm just simply doing a select from the data query that I already ran. So I can just use the normal Excel stuff to run it. And if you want to use Power Pivot, you could do the same, right? I mean, it would be very simple. So, so that's kind of an introduction of Hadoop on Azure and what Microsoft has done in terms of making it easier to use. It's currently in CTP, and you can go to hadooponazure.com and get the actual login and password and play with it a little bit. And people might ask me about performance. We're not currently, the way it's set up, we're not really doing the performance part yet, but later on we will make sure that that improves. So right now it's more of a develop environment, just showing you how things look. Just try to set up one of these at home. It will take you quite a bit of time, but just log on and get coffee, and you're back with a cluster ready to go. So, all right. So I think that's the presentation on Hadoop, and we can go back and look at who has submitted more jobs for the weather simulation. Let's see where they are right now. Weather. Did I spell it right? Okay. Ah, there you go. So we can list all the forecast, and okay. So you guys can submit a few more if you wanted to. Oh wow. Okay. Well, they're all running. So 7%, 18%. Yeah. So submit a few more, and let's just. And for those of you who have submitted, and you may not you are wondering where the heck it is. There is it's not really a bug; it's a feature. There is a feature that it hides all the jobs that are queued up in the back end. It only shows the ones that are running. So look, there's somebody put MSP in there, so it's kind of queued up. So so tonight, check the results on weatherservice.cloudapp.net, and I'll make sure that the source is going to go on GitHub as soon as possible. And I know a lot of people are trying to run use Azure to do compute without having to learn all these tools. This is a great example of just simply scripting, but also adding a front end to it for visualization. So there's a lot of pieces that's involved. There's Bing Map that's involved, and also there's a new implementation that I'm doing using MVC4. What that means is that it's Microsoft's web system. It's very similar to Ruby and Django, for those of you who know Python and Ruby well. So the idea is that you would be able to connect web API to provide OData, provide JSON, provide XML, or data format of your choice by simply creating a web application. It's very, very powerful, and it makes it super easy to be able to do. And making your data sources available. Another project that I'm working on is with the HDF5 group. So we're trying to take using F# to do IntelliSense on data sets that you bring in. So F# is a strictly typed programming scripting language, but which is perfect for data. And the nice thing is that a lot of the times we make errors in terms of programming, but in terms of data, that also happens. You may have selected the wrong column, you may have done something wrong. So having IntelliSense on scientific data sets like HDF5 format would be very valuable to reduce error and also make people more productive as a scripting language. So that's all I have to say, and I made sure that you got 7 minutes to get lunch. Thanks. Questions? Yeah, go ahead. Hadoop. Right. So the problem also becomes that you have a probably not a very fat pipeline between your machine and the cloud. So we have a much better pipeline. So you probably, once you have your data in the cloud, you probably want to run stuff in the cloud. And also there's a little bit of a problem with some of these models in the cloud. Like Hadoop obviously doesn't run as well in the cloud as on-premise because of the fact that we're not really. I mean, you can use the local disks, but ultimately you still have to put your content back into storage. So having that optimized. Meaning that physically move your machines closer to the data center or doing interesting things will eventually happen. I'm not embedded in the product team, so I can't really tell you anything because I don't know. But I think a lot of these optimizations are going to be in the works. But yes, you ultimately want to make keep your stuff in the cloud and run your analysis in the cloud. But it shouldn't prevent you from marshing up local data. So you can still keep your local cluster and run that, but you probably wouldn't want to send everything up. You probably want to send, maybe a selected few items and then join it with what's in the cloud. So it's really about common sense and data locality.
So the problem you think is really on the data volume and the communication between the cloud and the.
But universities generally are on internet too, so they have a really fat pipeline.
So
it might work better.
Yeah, several gig, maybe 1 gig.
Yeah. So maybe it's actually quite feasible. But you also have to keep in mind that latency may be a problem, even though latency is less of a problem for big data problem because they're batch already. But it's definitely possible. And it also depends on how much machines you can keep on premise, right? I mean, on premise people have limited real estate. I think that is the main thing right now is that I can't keep all 3 crays in my office. I have to keep it in the data center. If I had 40 of those, it would have to be in the cloud. So the ability to get a concentrated amount of resources or a continuous amount of resources is ultimately going to be in a public cloud or even a DOE type of setting. Any more questions? Or all right. Well, thank you all very much. Enjoy lunch.